All right, section 3.7. So, what we learned in section 3.7 are some business applications, or maybe more specifically, business applications of integrals. We're going to take what we've learned in chapter 3, namely how to calculate integrals, and apply that to a couple different business situations. The two applications that we'll look at really aren't connected, so what I'm going to do is make two separate videos for each of them, but neither one is all that major. So the first application gets into what's called the producer and the consumer surplus. And to understand producer and consumer surplus, you need to be comfortable with supply and demand. So the first comment I want to make about supply and demand is the standard way you graph supply and demand functions is to have your axes, switched for lack of a better word. I think most people, when they think about the demand for a product or the supply of a product, think about the quantity that you're selling as a function of the price that you charge, right? That makes a lot of sense. If you're a company and you don't charge a whole lot, then there's going to be a lot of demand. Consumers are going to really want your product because you're not charging a whole lot for it. And conversely, if you think from the supply side, if we're going to charge a whole lot for a product, then a company is going to be willing to supply a whole lot of it because they're getting paid so much for their product. I think most people, myself included, think that quantity should be up here on the y-axis and price should be down here on the x-axis because quantity is a function of price. However, that's not the way things are done in economics. In the classical models of supply and demand, we put price up here on the y-axis and we put quantity down here on the x-axis. I guess the logic, and I'm not even sure that I 100% buy it, is in some classical models, the price is not determined by the firm, it's determined by the market. So all the firm can do is decide what quantity they want to supply, and all the consumer can do is decide what quantity they want to buy. So quantity is sort of the independent variable. And then based on the quantity that the firm is willing to supply or that the consumers wish to purchase, the price is set by the market. So the price is a function of quantity. I guess that's the logic. I'm not sure I buy it, but what do I know? I'm just some math teacher. Anyways, if you get past that little objection, we have our supply and demand curves where price is given as a function of quantity. In red, we have the supply curve. Maybe I'll write it S of Q because my variable is Q, the quantity down here. Ignore the fact that this is lowercase and this is capitalized. And my demand curve would be D of Q. Again, because Q is my variable, D standing for demand. The supply curve has a positive slope as we expect. Firms will want to supply a higher quantity when the price that they're charging is higher. And if the price that they're charging is lower, they'll only be willing to supply a lesser quantity. And in blue, we have our demand curve, downward sloping as we'd expect. Consumers don't want to buy a whole lot of product if the price is really high, but if we lower the price more and more and more, the consumers are going to want to buy more and more and more of the product. That explanation sure made it sound like quantity was a function of price, as opposed to the other way around, but what are you going to do? Anyways, the point is you have your supply curve and you have your demand curve. And right now we'll keep this really general. I won't give you the equations of these curves at all, but typically you'd have an equation here describing this curve, an equation down here describing these curves, and both of them will use the variable Q, our independent variable, the thing that's on the x-axis. As you've likely seen in a business class, the point at which the supply curve crosses the demand curve is a very important point. It's the point of equilibrium. In this specific case, it looks like this point happens when Q is equal to 600 and P is equal to 5. What that tells us is that the equilibrium price, which is typically denoted as P star, is equal to 5, and the equilibrium quantity, which is typically denoted as Q star, is equal to 600. What I want to get at in this video is the concept of consumer surplus and producer surplus. So first, let's talk about consumer surplus. To understand consumer surplus, consider a point on the demand curve that is not our equilibrium price. So somewhere like way over here. What this point is telling me is, even if the firm charged a lot of money for their product, $10 for each one of their product, they'd still sell some of them. They wouldn't sell nearly as many as they do when they only charge $5, but they'd still sell some. It looks like in this case they'd sell 100. Another way of interpreting that is there's 100 people out there that are willing to pay at least $10 for this product. And this was just some arbitrary point that I picked. We didn't need to start with the 100. I mean, what I could do is come way, way, way over here where Q is equal to 1 and look at what P is equal to understand that there's one person out there who would be willing to pay whatever this price is for this product. I can interpret the height of the demand curve when Q is equal to 1 to be the price that the person who wants this product the most would be willing to pay. Looks like about $11 in this case. So there's someone out there willing to pay $11. And then the person who wants this product next most, maybe they're willing to pay like, I don't know, $10.99 or $10.98 or something. Those people aren't going to end up paying that much. They're just willing to pay that much. They really want the product. There's 100 people out there that are willing to pay as much as $10 for this product. But lucky for them, they won't have to, because the equilibrium price is only $5. So these people over here that are willing to pay $10 only have to pay $5. There's 100 people out there that are saving at least $5, the difference between the $10 and the $5, when they buy this product. We can think about the demand curve as kind of the maximum price that consumers would be willing to pay for this product. And if you compare that to P star, the equilibrium price, we see that these consumers are saving money. That amount that consumers paid compared to the max that they would have paid is what's called the consumer surplus. In our picture, this area shaded in pink represents the difference between the maximum amount that people would have paid and the actual amount that they did pay. This area in pink is the consumer surplus. And if we switch our point of view just a tiny bit, we can think about the producer surplus. The producer surplus, it's sort of the same idea. The company is willing to sell their product for less than $5. They just wouldn't sell this many of them. What the supply curve tells us is the price that the company is willing to accept for a given quantity of their product. So if you consider this point right here on our supply curve, what this point is telling us is that the company's willing to sell some of its product for as low as $2. They just wouldn't sell 600 units for such a low price. They'd only sell, it looks like, I don't know, about 380 units, whatever this value is. And there's nothing special about that too. They'd be willing to sell products for even less than $2. If we go over here on the supply curve and try to figure out where Q is equal to 1, whatever price corresponds with that Q equals 1, damn near 0, that gives us the minimum amount that the company would be willing to sell their first unit for, their cheapest unit, if you want to think about it that way. And if we think about the height when Q is equal to 2 or 3 or 4 or 5, that tells us the minimum amount they'd be willing to sell those next units for. The point is, from the company's point of view, because of this point right here, they're willing to sell 380 units for only $2. Fortunately for the company, they don't sell those 380 units for $2 because the equilibrium price is $5. So they get to sell all of their units for $5. So these 380 units that they were willing to sell for only $2, they get to sell for $5. They make extra money. That extra money, the additional amount that producers earn compared to the minimum that they would have accepted for each of their goods, is defined to be the producer surplus. In terms of our picture, the producer surplus is this area shaded in brown here, between the equilibrium price and my supply curve. Understanding the consumer surplus and the producer surplus are really important. It can help you make lots of different economic decisions. But I don't want to get too much into the theory behind these two things. What I want to show you is how do you calculate the consumer surplus and the producer surplus? Well, the good news is we can figure out each of these areas just by evaluating integrals. The way to think about it is, for the consumer surplus, let's figure out the area beneath the demand curve. This area outlined in red, the area underneath this demand curve from 0 to Q star. What this area in red would represent would be the total amount of money that consumers would be willing to pay for the 600 units that we're going to end up producing, our equilibrium quantity. Good news about this area outlined in red is it's pretty easy to figure out, right? It's just a definite integral. It would be the definite integral from 0 to 600, 600 being Q star, so maybe I'll put Q star up here, of our demand curve, D of Q, where our variable is Q. It's kind of annoying that this dq looks a lot like this dq, but they represent very different things. This dq is the symbol that denotes the end of our definite integral, so think like typically dx. This d of q represents the function that's pictured in blue here. Maybe some color coordination helps, I don't know. Anyways, this definite integral represents this area in red right here. But this area in red right here is not the consumer surplus. The consumer surplus is just the stuff in pink. However, if I can figure out the area in red, which I can from this formula, then I can come up with the area in pink if I just subtract out the part that I don't want. The part that I don't want is this rectangle in green. So I start out with the whole area in red, and then I subtract out the area in green, and that'll leave me with the area in pink, the consumer surplus. How do I represent the area in green? Well, there's a few different ways I can do it, but one way is to represent it as an integral. Again, it'll be a definite integral. We'll be looking at from 0 to 600. In other words, 0 to Q star. But this time we don't want the area underneath our demand curve. We want the area underneath this horizontal line right here. Okay, so what is the height of this horizontal line? Well, it's exactly P star, right? Our equilibrium price. So the definite integral from 0 to Q star of the constant P star, the height of this curve, will give us this rectangle in green. Because we're taking a definite integral, we need to put this dq sign at the end to signify to the reader that the q is our variable, but don't confuse this dq with this dq. This dq corresponds with this definite integral. It's the integral from 0 to q star of this function P star. This right here is our consumer surplus formula, and you can memorize it if you want, but really it's not that hard to understand what's going on. If you understand that the consumer surplus is the area shaded in pink, and you want to come up with the area in pink, well, find the area outlined in red, and then subtract the area outlined in green. And if you've been following what we've been doing all term with definite integrals, maybe you can understand why the integral in red gives us the area outlined in red, and the integral in green gives us the area outlined in green, and the difference between the two gives us the area shaded in pink. A couple quick comments here. I prefer this form of the consumer surplus formula. I think it's the most intuitive. It's the easiest to understand with the different pictures that we draw. But it's worth pointing out here that we're subtracting two integrals. So if you go back to kind of our fundamental knowledge about integrals, when we're taking the integral of something minus something, we can break it up into these two separate integrals. And in much the same way, if we have these two separate integrals, we can change it to a single integral where we're subtracting the integrands of the two different integrals. What I'm saying is this integral that we just figured out up here in pink is the exact same as what's written down here. This formula is a little bit shorter, so you might prefer it to this formula, but I personally find this one a little bit more intuitive. There's a lot of symbols going on down here, but don't let that confuse you. We're going to take the integral from 0 to q star, think from 0 to 600, of the difference between two different functions. The top function is this curve in blue here, my demand function, but from that I want to subtract P star, this height 5, so that I only find the area in between the demand function and this height of 5, the area shaded in pink. Since I have a definite integral, I got to write this dq at the end, but think about this more as a symbol that we pair up with this integral symbol to define the variable. Don't confuse this dq with this d of q. One final comment. When you're taking the integral of a constant, so in this case, the integral from 0 to q star of P star, really what you're doing is you're figuring out how much area is there underneath this horizontal line whose height is 5, in between 0 and 600. Really, all this thing represents is a rectangle whose width is 600 and whose height is 5. So if we want to know the area of that rectangle, we don't really even need to use calculus. You don't have to write it this way. You could just say, well, 600 times 5 gives me 3,000. So the area outlined in green right here is exactly 3,000. More generally, instead of using 600, we could say it's our equilibrium quantity. And instead of using 5, we could say it's our equilibrium price. What we could say is, instead of subtracting this integral, really all you're doing is subtracting a rectangle whose height is P star and whose length is Q star. Definitely don't need to memorize all three of these formulas. This one, and this one. You can kind of pick the one that you like the best. But I think it's informative to talk about how really they represent the same thing. It kind of gives you a deeper understanding of these integrals. You're probably ready for an example of this stuff, but before I show you an example, I just want to make the point that producer surplus is basically the same thing. If you want to know this area in brown right here, what you could do is figure out the area in green, which we've already figured out how to do, and then subtract from that this area in blue. How do we figure out the area in blue? Well, it would just be an integral, right? It'd be the integral from 0 to 600, in other words, 0 to Q star. And we want the area underneath this curve, which is our supply curve, so S of Q, and then we tack on at the very end a dq to define what the variable is for the reader. This area pictured in blue is represented by this integral. The producer surplus would just be the area represented in green, which we already figured out up here is the integral from 0 to Q star of P star dq minus that integral in blue. Start with green, get rid of blue, you're left with brown. Brown is the producer surplus, therefore this right here is the formula for producer surplus. Much like consumer surplus, you can rewrite that producer surplus formula by taking advantage of the fact that the difference in two integrals is just the integral of the difference. So this P star minus this S of Q all in one definite integral. Or you can say, really, you don't need to write the area in green here as an integral. The integral from 0 to P star of Q star is just a rectangle, and the area of that rectangle is P star times Q star. Just like we have 3 formulas for consumer surplus, we technically have 3 formulas for producer surplus. I wanted to mention all 3 in case you see a different version of it in a different class, but any of the 3 will do perfectly fine for our purposes. This video ended up getting kind of long, so I'm going to save the examples for the next one and end this here.